Welcome to the demonstration of the JSI workshop, How does an astronomical telescope work? Now let's look at how can we assemble a small astronomical telescope. First of all, let me introduce different instruments of the telescope system. We have a tripod here. The heavier the telescope, the bigger the tripod we need. Usually, the telescope manufacturer would have indicated the minimum diameter of the legs of the tripod. On top of the tripod, we have a mount for mounting the telescope. This is an equatorial mount. I will explain the working principles of different designs of mounts in a moment. We also have some counterweights. They are necessary to balance the weight of the telescope on an equatorial mount. And of course, we have the main telescope. This is a typical refractive telescope, perfect for some nice astrophotography. A dovetail plane has been connected to the body of the telescope. Next to the telescope, we have a star diagonal, which is useful to allow viewing from a comfortable angle. We also have here a fundoscope, a small auxiliary telescope to be mounted onto the main telescope. Then we have some eyepieces for viewing with our eyes. Let's assemble the telescope. First, we should install the counterweights to the metal bar connected to the mount. Fasten the screws to the metal bar like this. The positions of the counterweights on the bar do not matter. We will adjust them later. Do not forget to fasten the security screw. In case the counterweights slide down, the security screw is going to stop them. We should have a check afterwards. Then we can connect the telescope to the mount. There are two screws for tightening the dovetail plane. The bigger one is the main screw and the smaller one is the security screw. Put the telescope in place, and on the dovetail plane we can see there is a valley for the main screw. We should fasten the main screw before the security screw. Next, we can connect the fundoscope to the main telescope. Simply slide the fundoscope into position and fasten the screw. Then, we have the star diagonal. The fundoscope and the star diagonal are optional instruments depending on the position of the observing target. But honestly, the necessity depends on your experience. There is a movable mirror inside the diagonal to reflect light into perpendicular directions. Light entering the telescope will travel all the way through the telescope body to the rear exit where the star diagonal is connected to. Light can then exit from either openings of the diagonal where the eyepiece will be fixed. Lastly, we need an eyepiece in order to see the image by our eyes. Different eyepieces provide different angular magnification on a particular telescope. That's why you don't need to buy a new telescope. Just by changing the eyepiece, one can easily increase or decrease the magnification. After the installation is completed, we have to check the balance of the equatorial telescope system. Taking the intersection point of the two axes as the pivot, we can see that the moment or torque generated by the telescope body and the counterweights have to be balanced. Otherwise, the system will start to rotate along the equatorial axis. Since the distance from the equatorial axis to the telescope cannot be changed, we can only change the distance from the equatorial axis to the counterweights. If the counterweights are too close to the axis, the system will rotate in the counterclockwise direction. In contrary, if the counterweights are too far away from the axis, the system will instead rotate in the clockwise direction. Adjust the positions of the counterweights until the system is perfectly balanced. The direction of the telescope can be adjusted along two axes. One along the equatorial axis another along an axis perpendicular to the equatorial axis. Since celestial objects move in the sky due to the daily rotation of the Earth, one will need to adjust the direction of the telescope constantly. And here comes the advantage of using an equatorial mount. Since the Earth's rotational axis points almost exactly to the position of the North Star, or polar star, or Polaris, if we point the equatorial axis of the mount to the North Star, the equatorial axis will be parallel to the rotational axis of the Earth. For Hong Kong, this means to point the telescope to the north at an angle of about 22.3 degrees. Once we did this, we can find the target through the telescope. And once the target is found, we can just adjust the equatorial axis by making it to rotate in the opposite direction of the Earth's rotation. This can be done by rotating the axis manually or using an electric motor. But how to find the target? Well, if you are only observing bright and large objects like the moon, it is just a piece of cake. I'm sure that you won't encounter any difficulty in finding it through the main telescope directly. But if you are observing the planets or even deep sky objects, you may first utilize the fundoscope. The fundoscope has a smaller magnification than the main telescope, hence a larger field of view. A slight adjustment of the telescope's direction will only cause a small shift in the fundoscope's field of view. But for this technique to work, one must first align the axis of the fundoscope to that of the main telescope. This can be done by adjusting the screws around the fundoscope. When the two telescopes are aligned, the target visible in the middle of the field of view of the fundoscope will also be visible in the main telescope. Sometimes our target is very high in the sky, around the local zenith above our head. This is when we need a star diagonal. Using the current configuration, it is very uncomfortable to observe. Therefore, we should move the eyepiece to another opening of the star diagonal. We unscrew the eyepiece, fasten it to another opening of the star diagonal. Don't forget to cover the original opening. And then we turn this switch. The mirror inside the star diagonal will then make the light rays to reflect to a direction perpendicular to the telescope's axis. Now we can observe at a more comfortable angle. We should also learn how to read the specification about the main telescope. There are always two numbers printed on the telescope's body, F and D. F is the focal length of the objective lens for refractors or primary mirror for reflectors. D is the diameter of the light collecting opening of the telescope. If the ratio F over D is small, it is said to be a fast telescope, which provides a large field of view. On the other hand, a slow telescope has large value of F over D, which provides a small field of view. There is also a number printed on the eyepiece. This is the focal length of the eyepiece. The ratio between the focal lengths of the objective and the eyepiece gives you the angular magnification. For example, we have objective and eyepiece focal length of 600 and 20 mm respectively. So, the image we observe through the telescope will be magnified by a factor of 30 comparing to our naked eyes. Lastly, we can also connect our camera to the telescope for astrophotography. This is achieved by using a T-mount, which is an adapter for cameras. One side of the T-mount is connected to the telescope and the other side to the body of our camera. Remove the lens of the camera and then connect the T-mount to it. It can be fastened to the camera like this. Then, we fasten the camera and the T-mount to the telescope. Since now the total weight of the telescope has been changed, The positions of the counterweights should also be changed in order to keep the system balanced. We should adjust the positions of the counterweights. Repeat the trial and error procedure until the balanced position could be found. Here we go. Happy astrophotography. Let me introduce another mounting system. This time, we are going to use a typical tripod for cameras. Again, we have the eyepiece, main telescope with the founder scope, and the mount ready. This is another design of telescope mounts. It is called the out-azimuth mount. The out-azimuth mount is the simplest system convenient for small telescopes or camera telelens. Simply remove the ball head of the tripod and install the out-azimuth mount. The telescope can be connected to the out-azimuth mount in a similar fashion as the equatorial mount. Fasten the main screw and then the security screw. Connect the eyepiece to the telescope. Remove the telescope cover, and you have another astronomical telescope assembled. The out-azimuth mount has also two rotational axes. The azimuth axis is perpendicular to the ground, which allows the telescope to rotate in the azimuth direction. The altitude axis is perpendicular to the azimuth axis, which allows the telescope to change its altitude angle. Of course, one should also align the founder scope and the main telescope. The focal length f and diameter d of the main telescope are printed on the telescope's body. This time we have focal length 1400 mm and diameter 100 mm, so it is a pretty slow telescope with a small field of view. The focal length of the eyepiece is 32 mm, which gives me a factor of 43.75 magnification. Usually, we do not use automatic tracking technique on an out-azimuth mount because it requires two motors. When adjusting the direction of the telescope, we can use the fine adjustment screws to adjust the angles in the two directions in small steps. Finally, let me introduce a simple but powerful telescope, the Galileo Scope. It is the simplest design of astronomical telescopes invented by Galileo in 1608 and later improved by Kepler in 1609. The one I am holding is a redesigned version sold worldwide in the year of 2009, the International Year of Astronomy. It is still being manufactured, so you may still be able to obtain yourself one of these beautiful and powerful telescopes. Since it is so small, we don't even need telescope mounts. We will just use the ball head of the tripod. Fasten the ball head back onto the tripod. Remove the quick release plate and fasten it to the Galileo scope. You are now ready to observe the Moon or even Mars and Jupiter. Have fun!